Okay, so let's look at question H. And we've got y equals -1/3 x minus 1. Okay, so we're interested when we're looking at absolute value graphs in three things. One is the y-intercept. Two is the salient point. Well, I'll say 3 is actually the x-intercept, and 3 is the salient point. Now, you can't always get the x-intercept, because if we think of an absolute value graph shifted up, it's not going to have an x-intercept. The other thing we are a little bit concerned with is the m, the gradient. So if we think of a straight line graph, -1/3 would go downwards. So if we just look at this is a normal absolute value graph, and if it was negative, the absolute, it would look like that. So this would be x. And so -1/3 we can think of as it would go negative, but it would just be a flatter one because it's less than 1. So, but let's now look at it algebraically and see what we can come up with. So we'll get the y-intercept by making x equal to 0. So that's going to be -1/3 times 0 is 0 minus 1. So we know the y-intercept is -1. Then we're going to look at the salient point. So if you look at the other video that I've uploaded, the general formula for an absolute value graph is this. Now, it depends on what textbook you use, what they call P and Q. So some textbooks call it H, some call it B, some call it C, it just depends, but it just could be any letter. And so Q shifts it up and down, and P, if it's negative, shifts it forward, and if it's positive, it shifts it backwards. So what we going to look at, if we don't find the salient point, if we don't find x-intercepts, we still need to find the salient point. So the x-intercepts, if we make y equals 0, is going to be 0 equals -1/3 x minus 1. We take the y across, we get, so this is an absolute value here. And we take y across, -1 across to become 1, and we get -1/3 root absolute value x. If we divide this through by -1/3, we get -1/3 was absolute value, and we can never get an absolute value can never be negative. So it's never going to intercept. It's never going to, you don't have an x-intercept. But we can get the salient point, because the salient point is the point of the V. So if we look at just the normal salient point of a normal absolute value graph, there's no P and there's no Q. They're both 0. And so it's just on the x-axis, say there, it'd be that one there. So we look at the salient point of this, and we see that it's got -1. So the Q bit is -1. So the salient point is Q and P. Okay, as I said, there is a video on this. So we're looking at -1, and there's no P here. It's x minus 0 plus 0, doesn't matter. There's no P. And so it's going to be, our salient point is 0 and P. So now we know that our graph is going to look like as follows. We've got a y-intercept at, oops, at -1. And we've got a salient point also at 0 and -1. So the salient point is in the same place as the y-intercept. Well, that makes sense because it's just an absolute value graph shifted downwards. And because this is negative, it's also sloping downwards. So like what I've done here. So we can, and we know that it's going to be fairly flat graph. And so it's going to look like this. Now, what the teacher might want, so this intercept here was, let me do it in another color so we can see it. Since it was the salient point of -1, I'm just going to say -1 here. So it's the y-intercept is -1. Now, the teacher might want another point. So what you could do is you could simply just substitute in a value of x into here. So say we put in 1. So -1/3 times 1 will be -1/3, minus 1 will be -4/3. So this would be another point. I'll do it in yellow. So where x is equal to 1, y is equal to -4/3. And so we have this point of 1 and -4/3, which is just, it's -1,3. And then if you substitute in -1, you would get the same answer because -1, when it's absolute, becomes +1. And so it's a mirror. Okay, and so this is -1 and -4/3 as well. I should be doing this in a smaller pen. So I'll just do this point again. This is 1 and -4/3 is another point. So if they want another point on the graph, because the salient point and the y-intercept are the same, so you don't really have, you can't really draw lines through any points unless you substitute a value in for another one. So let's look next at J, which is oh wait, I did it completely different. I did -1/3 -1, which isn't even a question there. But that would be the graph of -1/3 1. So let's look at y, because that's -1/2.
Yeah.
Okay. I'm not sure if you were confused there. So this, if this is -1/2, I'm going to put the -1/2 here. It's exactly the same thing, and this is a half here, and this is a half here. And the salient point would be the same, because the only thing that changed is this is a half. And there's still no x-intercept. And so this, when we substitute in 1 here, we get 1. So -1/2 minus 1 is -3/2. So this would be -3/2. And so this point here would be 1. And then if we substitute a -1, -1 becomes positive. So -1/2 minus 1 is also. So the point here is, we're going to say is, that would be -3/2. So I'm going to take an eraser here. And just put in one of the points here. Okay, so this is -1 and -3/2. And this value here would be -1 and -3/2. Okay, so that's J. Now let's look at H. So I'm going to pause this and then I'm going to do H. Okay, so for y equals the absolute value of x plus 3 1/3, the y-intercept, we let x equal to 0. So let's just do this nice and properly so that you get the method marks. So you say y-intercept x equals 0. And then we say y equals, we say 0 plus 3 1/3 is equal to, and that's going to be 10/3 or 3 1/3, same thing. Then we try and find, see if there's an x-intercept, which we know is going to be nothing because if it's going to be that absolute value shifted up, it's not going to have one. But let's just show y. So we make y equals 0. And so we get 0 equals the absolute value of x plus, I'm going to keep this as 10/3 because I prefer it like that. We take the negative 10/3 across, or the 10/3 to become negative, and an absolute value can never be negative. So therefore, we say no solution, and that makes sense. There's no x-intercept. Now we just look at our salient point. So this is 1, 2, and 3. Our salient point is, remember, it's going to be P and Q. P and Q, or whatever you guys use as your, in your general form of the equation. So
We
P,
also use
do you use
P
P
and
and Q?
yeah.
Okay, cool. And so you know that if it's -3, then your salient point is 3.
Yeah, okay. So if it's negative and it's in like an absolute thingy, then it will always be positive.
Yes. And if it's positive, it's negative. So our salient point is, it doesn't matter if it's 0 because there's no sign for 0. And then Q is 10/3. And so we can look at our graph. It's at 10/3 is our y-intercept. And it just goes up like a normal absolute value graph. But again, we've only got the salient point and the y-intercept are, so I should really say 0 and 10/3 is the y-intercept, that point. The salient point and the y-intercept are the same when there's no value with x, because there's no left and right shift. So your teacher might want another point on the graph. So we would just, the easiest point is to sub in 1. So if we put in 1, we would get 1 plus 3 1/3, which would be 4 1/3. And so we could then put the point 1, and it would be 13/3, or 4 1/3. So that's 1. And then if you put a -1, negative becomes positive, and so it's mirrored. It's 1, it's -1 and 4/3. Okay, then just going to look at question E, and then maybe on the next page you can do some of the questions, having seen now how it all works. This one here is a regular absolute value graph that's been shifted to the right. So let's get a thicker pen. So 3E is a regular absolute value graph shifted to the right. So it's going to be y, x, and because it's shifted to the right, we say negative, because forward means it's negative with a 2, and that's all we need to do. And if we got the y-intercept, we would get, if we put a 0 in here, let's just do it. Y-int, we make x equal to 0, and so we get y equals absolute value of 0 minus 2 is equal to the absolute value of negative 2, and the absolute value of negative 2 is 2. And so that all works out.